Hello students, welcome to Saurav Sir's classes. Today we are going to solve a few questions on differential equation. The question is, let y1, y2 be two solutions of the problem y double dash t plus ay dash t plus byt is equal to 0 and y0 is equal to 0, where a and b are real constants. Let w be the Wronskian of y1 and y2. Then option A, Wt is equal to 0 for all t belonging to R. Option B, Wt is equal to C for some constant C. Option C, Wt is non-constant positive function. And option D, there exists T1, T2 belonging to R such that Wt1 less than 0 less than Wt2. So, by Abel's theorem, Wt is equal to C1 e to the power integration a dt, which is equal to C1 e to the power at. Now, as y0 is equal to 0 implies y10 is equal to y20 is equal to 0. Thus, we have w0 is equal to y10 into y2 dash 0 minus y20 into y1 dash 0, which is equal to 0. Now putting this value, we get w0 is equal to 0, which implies C1 is equal to 0. So w is equal to 0 is the correct answer. Therefore, option A gives us the correct answer. The next question is, let A is equal to minus 2, 1, 0, 0, minus 2, 1 and 0, 0, minus 2. xt is equal to x1t, x2t, x3t, and mod of xt is equal to x1t square plus x2t square plus x3t square whole to the power half. I'm writing this once again, maybe it's not visible. So mod xt is equal to x1t square plus x2t square plus x3t square whole to the power half. Then any solution of the first order system of the ordinary differential equation x dash t is equal to axt and x0 is equal to x0 satisfies. Now, if you'll solve this matrix, you'll get the eigenvalues to be minus 2, minus 2 and minus 2, and the eigenvector x1 is equal to minus 1, 0, 0. Now to find the other eigenvectors known as the generalized eigenvectors, let them be y1, y2. Then we have to solve the equations given by a plus 2I into y1 is equal to x1 and a plus 2I into y2 is equal to x2. Then the solution for such a system is given by xt is equal to c1t x1 plus c2t y1 plus c3t y2 into e to the power minus 2t, where cit I is equal to 1, 2, 3 are polynomials in t of degree at most 2. Now clearly option A holds on taking the limit, and the result, limit t tending to infinity e to the power minus 2t into pt is equal to 0 for any polynomial pt. Therefore, option A gives us the correct answer.